This lesson is a review of slope. Slope is a way of measuring how steep a line is. The line that you see on the screen right now is not very steep at all. It's horizontal, and in order to describe its steepness, mathematicians say that it has a slope of m, which is equal to 0. So we typically use m for slope. And in this case, it seems to make a lot of sense that the slope would be 0. What if you have a line that is steeper than that? Say this line in blue, or maybe one even steeper than that. Here's another line, tan, and then here's another one, each steeper than the previous. So there's different systems that could have been created to measure their steepness, but the one that mathematicians use looks at this line and says its slope is 1/2 or 0.5. You could express it as a decimal if you wanted. The tan line has a slope of 1 and the green one has a slope of 2. I'll explain later exactly where those numbers come from. For now, notice that as the line gets steeper, the slope gets bigger. Now imagine in your head the steepest possible line you can think of. Okay, that would probably look like this. That line is vertical. Can't get any steeper than that. Now, that line is so steep that no number is big enough to express its slope. So it's sort of like the slope is infinite. This little symbol right here means infinite. But technically, we would say the slope is undefined. So if anyone asks you, what is the slope of a vertical line? The correct answer would be either it has no slope or its slope is undefined. Either of those would be acceptable. Okay, again, just notice from the red line, the horizontal, that's has no steepness at all, that's got a slope of 0, and then the steeper the line, the higher its slope, all the way up to infinity. Alright, so where do those numbers come from? Why are those the slopes? Well, it might be useful to look at those same lines on what we call a coordinate plane. So here are the same 5 lines. Now they're drawn on a coordinate plane, so we can start assigning numbers to points and making calculations. For simplicity's sake, let's narrow our focus to 2 of those lines. Let's say the blue one and the green one. Notice that I've drawn in those staircases. That's just one useful way of thinking about slope. You're going to turn the ramp into a staircase, and you're going to look at those 2 staircases, or however many, and you're going to compare how steep they are. So which one is steeper? The green one. Here's how you actually get the numbers to assign to their slopes. So I'm going to get rid of these stairs just so that they're not distracting us. And then let's see. We want to find a point on the line. So there's 1. Its coordinates are 4, 2, 4 units over, 2 units up. And here's another one. What do you think its coordinates are? Well, start at the origin. 1, 2, 3, 4, 6, 7, 8. 8 units over, 1, 2, 3, 4 units up. So I would say that its slope is 8, 4. Its coordinates are 8, 4. So now let's use those numbers to find the slope. So essentially what we're going to do is we're going to see what is the ratio of this staircase. How far up do you go compared to how far over you go if you're climbing this staircase. So in order to figure out this distance here, which we call the rise, we're going to do, well, this is at a height of 2 and this is at a height of 4. So we can find that by subtracting 4 minus 2. I'm going to put that in the numerator. So that tells us that to go from this point to that point, I have to go up 2 units. How far over? 1, 2, 3, 4. Well, you could find that by subtracting 8 minus 4. So 8 minus 4. And then we do the arithmetic. 4 minus 2 is 2. 8 minus 4 is 4. And that actually reduces, so the best way of expressing the answer would be in lowest terms. The slope is 1/2. Okay, now let's look at the green line. Again, let's remove the staircase just so that it's not distracting. And let's do something similar. Well, wait a minute, let's find some points. So think about that point and that point. All right, well, what are the coordinates? This one down here is 2 units over, 1, 2, 3, 4 units up. So 2, 4. And this one here is, let's see, 1, 2, 3, 4 units over, 1, 2, 3, 4, 5, 6, 8 units up. 4 units over, 8 units up. So in order to find the staircase in this case, how far up did we go? Well, we started at 4 and we went to 8. So how far is that? That's 8 where we ended, 4 where we started. And then we're going to do the same thing for this horizontal distance right here. Started at 2, went to 4. So 4 minus 2. And do the math. 8 minus 4 is 4. 4 minus 2 is 2. And 4 over 2 is 2. So the slope of the green line is 2. Now, I like this particular example, putting these two together, because most people would agree that the blue line is not as steep as the green line. And so this sort of shows you why we do rise over run rather than the other way around. If this were to be the other way around, this one would be 4 over 2 and would have a slope of 2, whereas the green one would be 2 over 4 and would have the slope of 1/2, and that just wouldn't correspond to our intuition. We want steeper lines to have a higher slope. Okay. Here's the horizontal line. Let's think about finding the slope of this line. If you consider 2 points on the line, found their coordinates, this one is over 2, up 1, 2, 3, 4, 5, 2, 5. This one over here is 2, 4, 6, 7, and 1, 2, 3, 4, 5, 7, 5. Notice they share the same y coordinate, which means you have a horizontal line, because you can go as far to the right or left as you want, but you're always going to go up 5. So now let's do rise over run in the same way. So we ended at 5, we started at 5, we ended at 7, and we started at 2. So we get 0 over 5. And 0 divided by anything is 0. So the slope of this line, m, typically is the letter used for slope, is 0, which that's what we wanted. We wanted our horizontal line to have a slope of 0. Okay, let's look at a vertical line. Same idea, I just take 2 points. Let's do that one and that one. Alright, so this one is 1, 2, 3, 4, 5 units, but notice it's 5 units to the left, so I use a -5, and then it is 1, 2, 3, 4, 5, 6 units up. And then this one is also 5 units to the left and only 2 units up. Alright, this time I'm going to subtract 6 minus 2 and then -5 minus -5. And 6 minus 2 is 4. -5 minus -5, well, anything minus itself is 0. And then remember, you cannot divide by 0. If you try to, the result that you get is undefined, and that's because 4 over 0 basically means how many zeros does it take to reach 4? How many zeros would you have to add up if you wanted to get to 4? Well, you could add up as many as you wanted. You would never get there. So that's why the slope is undefined or does not exist. Okay. If you're working without pictures, and you just have the slope of, you're asked a question like this, what's the slope of the line with these 2 points? Well, here's the slope formula. So we'll plug into that slope formula. Remembering that, let's see, this point here, the 3, is the x1, and the 5 is the y1, 6 is x2. Okay, so plugging into that formula, m equals y2 minus y1. Well, 14 minus 5. 14 minus 5. You go from one y coordinate to the other. And then it's really important in the denominator when you do x2 minus x1, you start with the same point. So it's got to be 6 minus 3. You don't want to do 3 minus 6. You want to subtract in the same order. And then you get 9. 6 minus 3 is 3. You should always simplify if you can. That's 3. Okay? And you might wonder what would happen if you subtracted in the reverse order. If instead of doing 14 minus 5, you did 5 minus 14. Well, you can do that. It's just important to subtract in the same order with the x-coordinates as well. So this time, since we did 5 minus 14, now we're going to do 3 minus 6. And 5 minus 14 this time is negative 9. 3 minus 6 is negative 3. But you'll recall that a negative divided by a negative is positive, so you get the same answer either way. All right. Get out a clean sheet of paper using pencil. Please write your name, today's date, and homework number 1 in the upper right-hand corner. And then the first 4 problems are just like the example I just did. So for the first 4 problems, what you want to do is plug into the slope formula and find the slope of the line. And then on the 5th question, I'm asking you to think about something. I'm typically going to do that, give you 1 or 2 problems at the end that are more challenging and require you to go beyond what you saw in the video tutorial. Okay, so that's it for your slope review. Pause the video if you need some time to copy down these problems. Otherwise, that's it. Please have these done by the time you come to class tomorrow, and we'll go over it then.